In this video, we'll explore the basics of finding volume of a prism. First of all, what is volume? Volume is the space that a figure is going to occupy or take up. And as you know, it's measured in cubic units, sometimes written as units to the third power. Back in elementary geometry, you learned that in order to find a volume of a rectangular prism, you're going to use the formula volume equals length times width times height. So for that rectangular prism given, you would multiply the length, 5, times the width, 4, times the height, 3, and end up with either 60 cubic centimeters or 60 centimeters cubed. And this formula for volume is very easily to use for a rectangular prism, but it's not at all helpful if we want to find the volume of any other type of prism. So for those other prisms, we're going to use a generalized version of this volume equals length times width times height formula. The new formula that you're going to learn says the volume of a prism is equal to the product of the area of the base. And notice that in our formula, we're going to represent the area of the base with a capital letter B. That capital B is important, not to be confused with a lowercase b, which represents the length of one side of the base. So we're going to multiply the area of the base times the height of the prism. So when you see this formula for volume of a prism, you think area of the base times the height. Now if I go back to my rectangular prism that we started the problem with, and I want to use this same formula, I can. I'm going to consider the bases of this prism, the top and bottom. So the area of my base, capital B, would be equal to the length of the rectangle times the width of the rectangle, or 5 times 4, which is 20. The height of my prism is going to be the distance between those two bases. So the distance between the top and bottom of my prism are 3. So using that formula, volume is equal to area of the base, which is capital B, times height of the prism. The area of my base is 20. The height of my prism is 3. And I end up with the same exact answer I got when I calculated volume using the traditional length times width times height formula. All right, so let's go take a look at an example of a prism that is not a rectangular prism so that we can get some practice using this new formula. Number 1 says a common design for swimming pools is for the depth to gradually change from the shallow end to the deep end. They want us to use the dimensions shown in order to find the volume of water that the pool can hold. The most important question we ask ourselves is which pieces are our bases. We really can't go any further until we know the shape of our base. So if I were to look at the top and the bottom, I know that in order to be bases, 2 things have to occur. They need to be both parallel and congruent. Well, the top side of my pool and the bottom side of my pool aren't parallel. The bottom side gradually rises up from the deep end to the shallow end, while the top piece of my pool, where the water is completely level. So top and bottom can't be bases. What about the left side and the right side? The left side is a much larger rectangle than on the right side, so those rectangles can't make up my bases either. The front and the back are made up of those 2 trapezoids. Those are my pieces that are both parallel and congruent. Therefore, those guys are my bases. So my bases here are in the shape of a trapezoid. And again, it's very important for you to be able to recognize which pieces are the bases. So formula for finding the area of a trapezoid, area is 1/2 times the average of the 2 bases times the height of the trapezoid. So the 2 bases are going to be my parallel pieces, the 10, and this piece here is 4. So I'm just going to go ahead and substitute those into my formula. The height, this can be a little bit tricky. The height is the height of the trapezoid. So the height of the trapezoid is going to be the distance between its 2 bases. The height of my trapezoid is going to be the length of that blue segment there, which is 30 feet. All right, so now that I've fully substituted into my formula, I'm going to go ahead and get my calculator out. And I find that the area of my base is 210. And if I want, I can label that square feet. So now that I know the area of my base, I'm all set to go ahead and substitute into my volume formula. Notice that I'm going to write the formula down first. Volume equals area of the base times the height. So the base is my trapezoid, 210, times the height. And this time, height is referring to the height of the prism. In other words, the distance between the two bases. And the distance between my two bases is this 15 right here, the difference between the base at the front and the base at the back. All right, so I got my calculator out and punched those numbers in. And my calculator tells me that the volume of the swimming pool is 3,150. My units here are feet, so it's either going to be cubic feet or feet to the third power, however you want to express that. All right, so there's the swimming pool. Number 2 says, or gives us, that the volume of the rectangular prism is 6,000 cubic feet, and they want us to find the surface area of the prism. Because this is a rectangular prism, it's sometimes easier to use that volume equals length times width times height formula. But again, you can really use either of the two formulas and you'll end up with the same answer. They tell us the volume. So in this case, we're going to be working backwards. I'm going to plug 6,000 into the formula for volume. The length, width, and height are 30, 20, and x, and it doesn't matter which order you express those in. So I'm going to go ahead and on the right-hand side of this equation, I'll multiply my 30 times my 20. To undo a multiply times 600, I'll divide by 600. And I find that the length of this base edge here is 10 units long. So now I want to find the surface area. The surface area is going to be the entire surface area, and it's made up of 6 different rectangles. So I'm going to go ahead and say surface area is made up of 6 rectangles. I'm going to go find the areas of each of those rectangles. And I'm going to start with the area of the rectangle that makes up the front and the back. The front of the box and the back of the box measure 10 by 30, which makes the area of each one of those rectangles 300. The left side and the right side of the box measure 30 by 20, giving us an area of 600 square units. And then the last piece that we need to consider is the top and bottom of the box. Top side and bottom side measure 10 by 20, giving us an area of 200. So now my entire surface area is going to be made up of 2 of these rectangles that measure 300 square units each. 2 of these rectangles that measure 600 square units each, and 2 of the rectangles that measure 200 square units each. So now when I go add those areas together, I end up with 2,200 in either feet squared or square feet, however you want to express your units. It's square units though, because we're finding area. All right, so up at the top of the next page, as always, in your own words, summarize the key ideas and important understandings, and then see if you can apply what you've learned in order to find some volumes.